Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. If you've been following some of my integrated Math 3 videos, what we've been doing with solids, and you want to step on inside and learn a little bit more about them, let's do an overview. I got 4 problems for us to do as an overview, finding the surface area of anything among prisms, cylinders, pyramids, cones, and spheres, and even composite solids with all of them as well. I'm going to give you a PDF of this one down below as well if you'd like to try it for yourself. But again, it's just 4 problems, but it's just a culmination of the things that we saw. So I'm going to go through them a little bit faster generally than I would teach them and slow it down and stuff, with the exception of I want to show you some of the formulas to begin with and make sure that you kind of have those in a nutshell. And then I'll run through the problems as they're kind of asked for them to run through. There were ones that I made, but as ones that you're asked to run through. So here's what the set's going to look like to start with here. It's a practice quiz for my kiddos. 2 problems right here, a cylinder, a triangular prism, and then down here you got a composite solid of a cone with a hemisphere, and then you have 2 rectangular prisms, one hollowing out inside of the other one. So those are the 4 problems that we're going to be doing here. Before we do that, let's go ahead and get started, and let's just get the formulas, all the different formulas for these surface areas. And in that case, the lateral areas of these as well. Some will be more specific, some will be less. It just depends on the situation. So let's start with any sort of prism. If you have a prism, the surface area is the lateral area plus the area of both of your bases. There should be a base on top and bottom, or whichever ways that they're actually laid out, but 2 bases right there. And the lateral area, if you unfold that, we are going to be doing the perimeter of the base times the height. Now you're going to see me doing a net drawing for a prism. I think it's a triangular prism. I'll do a net drawing of it so you can see that exact kind of thing. Cylinder, a cylinder is like a circular kind of prism. So it's also going to be lateral area plus the area of both your bases. The lateral area here is also perimeter of base times height, but because the perimeter is truly the circumference, because your base is a circle, it's really 2 pi r times your height, circumference times height, like that, in a more specific way, if that makes sense. Just more specific as we do that. Okay, the pyramid and the cone are, a cone's like a circular pyramid. Your surface area here, there's only one base, and your lateral area is kind of the it just looks a little different. Lateral area plus the area of a singular base, and your lateral area here is going to be, what's a pyramid? 1/2 perimeter of base times the slant height. The one that's going down one of the faces of the triangles in the perimeter, not the one that goes through the middle, like we say height for volume of a pyramid, like what we did for a previous video, I suppose. And then the cone, same kind of thing here as the pyramid. It is going to be lateral area plus area of the singular base, only this time your base is a circle. And I'm not giving you base formulas right now. Your bases for circles are pi r squared. These all depend on what kind of shape it is. Is it a square, a rectangle, a triangle, a hexagon? Whatever it is always changes, but the lateral area is a consistent thing. In this case, your lateral area here is pi times the radius times the slant height. Lastly, you have a sphere. And in the sphere, your surface area is going to be 4 pi r squared. Now, it's possible that we'll be dealing with hemispheres. In fact, I think in that solid, in the composite figure, I do think that we do have a hemisphere, in which case I kind of like to consider a lateral area being the actual hemisphere part, and then if it's enclosed, there's an area of a base right there. But the lateral area would be 2 pi r squared, half of it, and then that's kind of where we go from there. So you might see that come into play as well. All right, so let's jump into these problems here, guys. I'm going to start with number 1. On number 1 here, we have a cylinder with a diameter of 20 kilometers and the cylinder's height is 8 kilometers. Now, the first thing I'm going to have you do is construct a net drawing labeling all provided parts. This might help you with your formulas a little bit more. I don't know if I'm even going to quiz my students with that. I just want to know they still can kind of do it. And what happens here, guys, is we get to unfold the sides, the lateral facing right here, into just one large rectangle like this. Now, in this large rectangle here, you do have an 8 kilometer height, like that. And then there's a circle that unfolds on top and a circle that unfolds on bottom. So as far as labeling the parts that they give us here, I got a 20 kilometer diameter right there, and then 8 kilometer thing right there. That's really all to label based on what they gave us. However, you could always do more if I wanted to find out this length here. Remember, that's equivalent to the circumference of this guy, but that's something that I'm going to be getting on its own anyway. I just wanted to get that drawing in, and hey, remember though, that will be that circumference, right? Circumference 2 pi r times height. So there's that net drawing. Okay, so let's keep going down with this problem. So to get the surface area down here, leave it in terms of square kilometers in the end, what I need to do is I need to find the radius. The radius is going to be half of 20 because the diameter is 20. So 20 over 2 is 10 kilometers. We do know that the height of this prism is 8 kilometers. So the lateral area, let's start with the area base. The area of the base is going to be pi times r squared, which is 100 pi square kilometers. This lateral area is 2 pi r, the circumference of it, times the height. So 2 pi times 10 times the height, which is 8. 2 times 10 is 20. 20 times 80 is 160. We get 160 pi square kilometers. And so your surface area is going to be LA plus 2b. 2 times 100 pi. So 160 pi plus 200 pi. That's going to be, we're doing in terms of pi. So in terms of pi here, that's going to be giving you 360 pi square kilometers exactly. Excuse me. So there's the exact one there in square kilometers, getting surface area by kind of deconstructing this thing, getting it. And yeah, there's the labeling. We are good. Excuse me, good to go on that one. Let me move my face for the other problem here. There we go. I have hiccups. I might have to pause this. Jump back into it in a second. I hate when this happens. All right, number 2. Number 2, we have a triangular prism. 2 triangles opposite each other that meet with rectangular lateral faces there. I'm going to make the net drawing, and what happens is, remember, the triangles are the bases. I do have 3 rectangles, 1, 2, and 3 right there that I'm going to unfold all together in this net drawing. Now, there are different kinds of net drawings based on what you do. Prisms and cylinders, we unfold the rectangles of the thing in a larger rectangle. If I had some sort of like pyramid, I would like unfold it like this from the base outward. So those things kind of happen as well. But this one makes the most sense with regard to what we want to do. I have 3 rectangles divvied up right here. 1, 2, 3. And the rectangles have the following lengths. 6, 8, and 10 meters going across. So 6 meters, 8 meters, and 10 meters. And then there's a triangle unfolding on top and bottom. Now you can draw in any of the ones that you prefer. What you do need to do, or what's important though, is that there's a right angle between the 6 meter and 8 meter guy. So if I draw it from the 8 meter here, I want to draw the right angle going up like that and just make sure that I note that, hey, that's the 6 meter part. And if you want to keep going, like that's the 10 meter part right there, right? So that's how that thing would unfold because of the right angle that comes from it. And then I just won't label the bottom because it's all the same, but because they're congruent as prisms do. And then we have a 4 meter height. The distance between your 2 bases there is 4 meters. So there's a net drawing of that one. I don't do that too many times with my students. In fact, I only really last did net drawings with them when they first learned the formula, before they learned the formulas of these things, and then it helped them understand the formulas. Either way, here we go. Let's go ahead and determine. I kind of want the net drawing to show the perimeter part. So the surface area is lateral area plus area of both bases. The area of either base here, area of a triangle is 1/2 base times height. If I call 8 my base, 6 would be my height, because 6 is perpendicular to the 8. Half of 8 is 4. 4 times 6 is 24. I got 24 square meters for that one. The lateral area is the perimeter of the base, 6 plus 8 plus 10, times the height of 4. So 6 plus 8 plus 10. That's 24 times the height of 4 is 96. So your surface area is LA plus 2B. 96 plus 2 times 24. 96 plus 48 is 144. So that's going to be 144 square meters. I'm going to make sure I was using meters the whole time here. All right, so 144 square meters. No pi, no in terms of pi, nothing like that. All right, so those are the first 2 there. So we got a cylinder, we got a triangular prism. On this next page here, the last 2, like I said, I want to kind of work fast. I'm within 10 minutes so far, and I did formulas with you. Nice. So now we're going to have a cone with a hemisphere, and then 2 rectangular prisms. It looks like pyramids did not make the cut. If I were to maybe do this again, maybe I would have done it instead of the triangular prism, or maybe somehow put a pyramid inside here. But you know what? We're gonna work with it. All right, so this time we're going to round things to the nearest hundredth. No net drawings, just go ahead and solve these things. So as far as surface area goes, just keep in mind that base, not only of the cone, but also the base of the hemisphere, that's covered by object stuff. It's not a part of your surface. So the only surface is the lateral area of the cone and then the hemisphere lateral area, if you will. Now, if I wanted to get, let's call this like figure 1 and figure 2. If I wanted to get the surface area of the cone here, I do need to get the slant height L. I did need the radius R, which I have. Looks like your R for both. Your R for both of these is going to be 7 centimeters. Remember, even the hemisphere also has a radius of 7 centimeters right there. Now, the slant height is going to be solved by using Pythagorean theorem here. We're going to be doing 7 squared plus 24 squared equals L squared. If I want to call it L1 for the slant height for that shape, it's okay. There's only one slant height here. 49 plus 576 equals L squared. 625. So L squared is 625, and I know that's a perfect square there. So square root of both sides, we get L is 25 centimeters. So that one's exact right there. So 25 centimeters for L. That ends up being your slant height for this. Lateral area is pi times radius times slant height for the first guy. So LA for the first guy is pi R L, like that. 7 quarters is $1.75. So 175 pi. Now I'm going to leave it exact for now. Never round early, because we are going to be adding this with the surface area of the lateral area, I should say, of the hemisphere. This just that bottom part there. So that's the lateral area of one of them. The lateral area of the second guy here is going to be, radius is still 7. So not 4 pi r squared, 2 pi r squared. So 2 times 49 is 98. So we're going to get 98 pi square centimeters for that one. So the surface area of the total will just be adding up 75 pi with 98 pi. 175 pi. 175 pi plus 98 pi. That should be 273 pi square centimeters right there. And using a calculator here, if you want to see it, using a calculator, 273 I should say, times pi will give us 857.65 when you round to the nearest hundredth there. So 857.65. This is approximated because we cut off some of the things there. This is exact. This one here is approximated based on what's there. And these are all square units for these ones. So there's number 3. Last one, number 4. You have, and this is the trickiest one for people to generally do, but you have a rectangular prism on the outside, a rectangular prism on the inside. Let me move myself again here. And, the prism on the inside is hollowed out, so this part's missing. So what that means, if you were just to see me color this in, this is a part of your surface. That is, and technically also everything on the inside. So all this stuff right here, this is surface. It's on the inside. If you can paint it, it's surface, and that counts. So here's what we're going to do, just logically. I'm going to take the surface area of the outside one here, okay, the whole outside rectangular prism. And then I need to subtract and add some other things, because what happens is this top base loses, I'm just talking about just this opening right here, it loses that hole as far as surface goes, and it obviously loses it on the bottom here too, but then it gains inner wall right there and here and on that side. It ends up gaining wall that we have to add in. So I'm going to take the surface area of the whole big one. I'm going to subtract the 2 bases of the smaller one, because those are the holes, and then I'm going to add in those inner walls, the lateral area of the smaller one. So I want surface area of big, which was lateral area plus area of both your bases. I want the area of, and then I want the lateral area and area bases of the other thing, so I can subtract the bases and add the lateral area. And then I'm going to get a whole answer, which I don't think I need to round anything. 2, 3, 4, 5, 6. All right, here we go. So 4 by 5 by 6 right there. So if I wanted to get the area of the base of the big guy, area of the base of the big one, if I call that figure 1, and the small guy's figure 2. So that's going to be a 4 by 5, which is 20 square centimeters. The lateral area of the big guy is perimeter of base times height. So the perimeter of the base is 4 plus 5 plus 4 plus 5. You can't see the back sides, but please understand it's a rectangle. 4 plus 5 plus 4 plus 5 times the height, which is 6 centimeters. 4 plus 5 is 9. Plus 4 is 18. 18 times 6. Let's do 6 times 6 times 3. 36 times 3 is 108. So 108. Oh, I could have done 18 times 6. Square centimeters. So your surface area of the whole big guy is LA plus 2B. So that's 148 square centimeters. Let's book it and leave it as we get the lateral area and base areas of the other guy. I won't need to compute the whole surface area because I'm not subtracting the surface area. I'm just subtracting the bases and then adding in the lateral area. So the base, each base is a 2 by 3. You can see that right there. It's a 2 by 3. So shape 2, the area of the base is 2 times 3, which is 6 square centimeters. 2 of those will be subtracted from the whole surface area of this guy. And then the lateral area of the second guy, once again, it is perimeter base times height. So 2 plus 3 plus 2 plus 3 times, once again, 6, right? It's still the same height of that one now. So 2 plus 3 plus 2 plus 3, 5 plus 5 is 10, times 6 is 60 square centimeters for that lateral area. So the surface area of the total here, what I'm going to do is I'm going to take the surface area of the big guy, 148. I'm going to subtract 2 of these bases. What did I do? I just wrote square centimeters here. Is 6, right? It's 2 times 3. 6 square centimeters. I'm going to subtract 2 of those 6s because I'm going to subtract it from the top and bottom. Those are holes there. And then I'm going to go ahead and add the lateral area of the inner wall there, which is 60. So in the end, that's going to be 148 minus 12 is 136 plus 60 is 196 square centimeters. And that's it and that's all. I didn't get to cover pyramids in here, but pyramids also contain slant heights. If there's one more thing I can mention about pyramids is we'd be dealing with regular polygon bases, like a square or something like that. So, we have a slant height that would go down the middle like this. You might have to do some Pythagorean theorem on things like that with the actual height. And then this length is half the length of something like that. Those kinds of things really come into play when we deal with pyramids. This didn't seem to have it, so my students can expect to have it on a quiz for sure. This is just practice of just anything goes, basically. That's kind of the idea behind it. So anyway, there's that there. I hope that you found the PDF as well for what you need. That ought to do it for this one, guys. This is Mr. Robinson. I want to make this one a quick one because, I don't know, I just wanted to. Thank you so much. Take care.